Hi everyone, I am thrilled to inform you that we have a partnership which will assist in fueling artificial intelligence in African mining. We as Fratelli Analytics through Fratelli Capital have partnered with Global Links Corporate Training and Consulting to champion a Pan-African AI revolution in the mining sector. Our cooperation is set to empower professionals with accessible machine learning training, aiming to elevate efficiency and sustainability across Africa's mining industry. Joining forces with Global Links is a significant milestone, aligning with my dedication to integrating advanced technologies into mining. We are poised to transform the mining industry, fostering a future where technology propels progress and prosperity. So please stay tuned for more updates on this transformative journey. I am a fervent advocate for AI in mining. I am committed to driving innovation and sustainability through technology. So for today's presentation, we'll just be looking at smart mining with the key of unearthing efficiency with artificial intelligence. AI will be pioneering the mining industry. But before we start, let me just give you a brief profile about myself. I have a PhD in mining engineering, which I obtained from VETS. I have also a professional industry certificate, like Mine Manager Certificate of Competency. My expertise span out in mine design, mine planning, financial valuation, equipment selection and optimization, and then of course machine learning and with Python programming. Commodities I've been exposed to and where we have done some work include the platinum group metals, gold, coal, manganese, chromium, vanadium, amongst others. Now, let's look at the content for today. We will look at what is AI, what different levels of AI exist, what types of AI that one can adapt in the mining space, where is AI currently being applied, and also the possible areas where it can be applied in the mining space. Then we also look at, now in detail, looking at machine learning and the different learning models that exist. So let's first define AI. AI is a simulation of human intelligence in machines that are programmed to think and mimic human-like cognitive functions. This spans in simplicity in these 5 areas, looking at natural language, learning, problem solving, decision making, and pattern recognition. So let's look at natural language. Natural language allows us to analyze a vast amount of data, which is in text form. This can come from safety document, regulatory compliance, community feedback, as we do our stakeholder engagement, from which then applying natural language processing, we can be able to extract valuable insights and trends from that data. Then in terms of learning, we have vast data in our servers in the mines, whether coming from control room, coming from sensor-based data sources, but that historical data can actually be turned into information. And by using the machine learning or artificial intelligence, we can actually learn from this historical data on things like, for instance, equipment performance, failure patterns, safety incidents, and safety performances. When it comes to problem solving, you can actually now use analytics to be able to identify underlying causes of operational issues. For instance, if you wanted to look at machine breakdowns, what is really the root cause for a machine to break down? We can actually be able, through collecting of appropriate data, we can be able to determine the exact cause and then be able to solve that problem. So the data will come from various sources, such as mentioned. Machine can be sensors, geological survey, you can be using drones to get data from that, and then from there you can then analyze it. And also, we keep our maintenance record as well that can be used. So there's vast areas where machine learning can assist us in ensuring that we solve the day-to-day problems. Once we have solved the problem, the next key thing is to make a decision. So AI will assist us to ensure that the decisions that we have made have really been tested, and they will actually be able to mitigate risk associated with some of the activities that we'll be analyzing. And the key thing, of course, is to ensure that our workers go home safe. Zero harm is non-negotiable. So by using machine learning tools, we'll be able to enhance our decision making, especially when dealing with a vast amount of data. And with prescriptive predictions, you can be able actually to get recommendations from an AI model. So it also assists to make decisions and also aid in what decision to be made. And then we're looking at pattern recognition as the last aspect on this slide. So we have image recognition algorithms which can be used to analyze geological images such as those taken through satellite, drone footage, and then from that you can be able to identify potential mineral deposits based on visual patterns and spectral signatures. And this will actually revolutionize exploration as we know it, because by the time we put a drill rig to drill the boreholes, we will then be at some level of confidence in knowing that that particular area that we want to explore further does contain that mineral of interest. Now, we said that AI is about training machines to think like humans. Now let's look at the three types of AI. One is artificial narrow intelligence, the other is artificial general intelligence, then lastly we have artificial super intelligent, which at this stage is still at its theoretical phase. Let's look at narrow intelligence. So narrow intelligence deals with a very narrow range, so it's a problem-specific application of AI. So it's designed for that task, therefore it lacks the general reasoning that we can get from AI, which is learning. So it doesn't have learning capabilities. So that's why we call it narrow. So it's a problem focused. So it can be linked to traditional programming. So here you can use it in simple forecasting supply chain information, identifying areas where you can save energy within your value chain in the operation. Then the next one that we have is artificial general intelligence. And then this one is now able, the sole purpose for artificial general intelligence is to replicate human-like intelligence. It possesses the ability to understand, learn, and reason across diverse domains. As we've seen previously in the previous slide, I spoke about that AI assists us in making decisions. So it's through this learning capability of AI that you can be able to reason. Therefore, from reasoning, then you can get recommendations of the next steps we can take. In this case, you have sorting, we have autonomous vehicles as one of the examples. But of course, there's a myriad of application that AI can be used in. Then lastly, we have the super intelligence, artificial. As I stated that it is at a theoretical phase, artificial super intelligence surpasses human intelligence in every aspect. It represents a level of AI beyond human capabilities. For this particular webinar, we will be looking at the general intelligence and with a close focus to machine learning. So we have looked at the types of AI, and then the types of AI that we have artificial intelligence itself, we have machine learning, which is a subset of AI, and then we have deep learning, which is a subset of machine learning. And artificial intelligence, of course, is a branch of data science. So let's look at AI as is. AI is a popular branch of computer science that is concerned with building intelligent and smart machines, which are able to perform intelligent tasks. Just like as a normal human being, we'll be able to think, analyze the data, and then from there make informed decision. AI also assists in that. So with the rapid advancement in machine learning and deep learning, then the technology industry is transforming radically. And the mining space is going to benefit from this development in the technical space. Machine learning is a type of artificial intelligence that enables machines to learn from data and deliver predictive models. So we have an ordinary system that is traditional, from which then we have infused a bit of AI on that system that can take us probably to a narrow intelligence. Then now we advance to general artificial intelligence, where we now have machine learning, which now does not depend on an explicit programming in order to be able to analyze and learn or understand the data that is fed into it. However, going into the nitty-gritties of the application or the backdrop of machine learning is more complex. It requires a lot of mathematical processes and understanding. For this particular webinar, we will look at the application, not the mathematics and statistics that it comes with that. So the model for you to learn and predict accurately, it is dependent on the data that is fed into it. So if you feed poor data, that means also the prediction will be poor. But the key thing that you can take from machine learning is that it will give us predictive models. So it learns from the data to then predict. Then as you feed it with new data, it takes that data in as well, and it improves its learning ability. So it is a continuous improvement. The other form of artificial intelligence, which is a subset of machine learning, is deep learning. The deep learning is concerned with algorithms that are inspired by functions known as artificial neural networks, that is mimicking the way the brain operates and the nerves of a human being operate. In this case, a computer model can be taught using deep learning to run classifications using input such as pictures, text, or sound, then from which then it can be able to learn, and then it will then be able to give the appropriate response. Let's look at the three types of AI across board. You have artificial intelligence, you have machine learning, and deep learning. As I said earlier, AI represents simulation of a human-like intelligence in machines, while machine learning is a practice of getting machines to make decisions without being programmed, as compared to traditional programming, which we'll see later. Deep learning is the process of using artificial neural networks to solve complex problems. So the aim for AI is to build machines which are capable of thinking like humans. The aim for machine learning is using data so that machines can learn and be able to solve problems. For deep learning, the aim is to build neural networks that automatically discover patterns for specific features or specific levels that one will be interested in without really being trained like in machine learning. So these are the different applications of artificial intelligence, and this is not only in mining, it spans out to other industries as well. So you can look, we have supply chain, human resource, risk management and analytics, real-time operations management, predictive analytics. So these are the areas where one can be able to use AI to improve their business efficiencies. Here we're just showing some of the current status of AI. In this case, the first graph is showing us that the revenues that were forecasted for 2025 indicate that $8.1 billion will be generated through static images, image recognition, classification, and tagging. Then you will have your predictive maintenance around about $4.7 billion as revenue generated by next year. So it just shows us the opportunities that lie ahead in terms of applying artificial intelligence in the mining space. There are countries that have shown a high penetration rate in terms of skills in the AI space. You have US, China, India, Germany, and Israel. These are the leading companies in terms of their constituents focusing more into the AI space. And then also looking at organizations that deploy AI, we have external communication, that is where it's currently largely used. And then also tracking customer relations or interaction, where one needs to track the responses and the experience of clients. That's where also is used, looking at 66%. But then there are various areas where it will still be used, and it's very promising that to see that none of these areas are at the lower end. They're actually advancing towards the upper end of applying AI in their operations. Let's look at the trends of AI. Again, this is not only in mining, it's just looking at the trends of AI in general. This is by 2020. It shows that the top 10 areas where AI was being applied include robotic process automation, looking at AI improving business-to-business dealings. Also, we have AI-powered chatbots. That's where you speak to a machine, and now that means you have more virtual offices than actually in-person offices, so people can get a prompt response for on fundamental questions. Then also there's advanced cybersecurity. As in the mining space, we're all aware that data protection is very important. So there is an advanced application of AI in the cybersecurity to prevent fraud and hacking as well. Now let's drill down to machine learning as a subset of artificial intelligence. So the first part here, we're looking at traditional programming. Traditional programming, what you will have initially is that you just input, you'll have your data that you have cleaned, of course, and it's ready to be used. And then you write a specific program that will understand that data and solve that particular task that you are interested in. So it involves manually specifying the rules and instructions. Then you put that in a computer, and then it will give you the output. And that is a static output. Whereas when it comes to machine learning, you will then have your data. Of course, it has to be clean data. Talk about data integrity. It has to be clean data that is fit for purpose. And then that data will also have output. The output is what you are tracking. So you'll have features, then you have the output, which will be your labels. Now you want to track and train a model to see if that model can be able to predict, using the current data, is able to predict the output. That is a training of the model. Train the model and then test it. So once you are happy with the output in terms of accuracy, you have measured the accuracy of your model, and it does it shows that it is able to learn from the test data and give you a proper an acceptable level of accuracy. You will then have a model that now you can use. That model can then be used with new data for prediction purposes. Continuing from the previous slide, looking at the traditional programming and machine learning, as I did mention earlier, in the traditional way, you will have data fit for purpose, and then you're gonna handcraft the model, then feed it into a computer, and then you have result, and that ends there. Should you need to do a task related to that particular problem, you will have to again handcraft a new model. So that is now time consuming. On the other side, we have machine learning, which we will have sample data. We'll clean that data so that it can be a proper data that can be used or fit for purpose. Then that data that you have should have the expected outcomes. What result are you expecting to see? Then you then select a particular algorithm, and then you feed into the model. And then the learning part is to take the original data, to train it and try and learn from the data. From there, it can then test itself against the expected result. If it can predict the expected result, then it's a good model. If it does not, then it's a bad model. Then you take that model and feed in new data. When you're feeding new data, now you are doing the prediction. So that's where you can now be able to, all the time, you don't have to now train the model with the expected result and then solve the problem. Now all you need to do is to put new data and see what the output is. New data, see what the output is. So the model, and as we feed new data, the model also improve its learning capabilities. So that's why I say it's a continuous process. So what are the differences between the traditional programming and also the machine learning? Traditional is rule-based, it's for a specific task. It is deterministic, it cannot change it. For that particular problem, it's only for that problem only, and therefore it is not adaptable. While we go to machine learning, which is data-driven, and it's probabilistic because it learns from probabilities. So you have given me this data, you say I must predict this particular outcome, then it will use probabilities to learn on the data in order to be able to accurately predict the outcome. And of course, it is adaptive, as you have, if you want to put new data, just add new data, and then it will give you the results because the model is already there. Let's look at the process. How do you apply machine learning? So the first thing, and I've been mentioning this over and over again in the previous slides, data is important. So let's start with identifying the problem. What is the problem? We have to define your problem, and it should be, and set a clear objective. What do you want to achieve? So I have a problem of cost. Do I want to minimize the cost or maximize the cost? That's a clear objective. If I want to minimize the cost, then that's the objective that I'm taking with. Then I must go and collect data in relation to that particular problem. Then in that particular problem, the data will have features and labels. Features is what the machine will be learning from, and then labels will be what the machine will be trying to predict that particular output. Data can come from sensor, if you're using machines, for instance, or data can come from your control room servers where you store in your normal database. Once you have your data, you have to now prepare your data, looking at cleaning your data, data wrangling. So you want to ensure that the data is fit for purpose. You remove duplications. If you have null empty spaces or null values, you can apply your own rules on how you handle missing values and things like that. Once we are comfortable that the data is ready to be processed, you then have to select the algorithm. Which machine algorithm is suitable for this data? We'll see later when we're looking at the different types of learning methods, which data is applicable when using which particular algorithm. Once you have that, then you take your data set, then you split it into two parts. One part is training, the other part will be testing the model. More of the data must be on the training side so that the model can have enough data to learn from. So in that case, you probably have a split of 70-30 or 80-20. Of course, it depends how much data you have, what is the problem you're trying to solve. That will inform the split. And then once you have trained the model, that means you're going to fine-tune the input parameters. While we say that there is not programming, but you've got to decide the different parameters which will affect whether you're going to have a local optima or you're going to have a global optima, depending, that's talking to solving the problem. You're going to get a quick solution, which is false, or you're going to get, it's going to take time to get a solution, but it is more accurate. Once you have trained the model and you are happy with the accuracy levels, you then use the test data to test the model in terms of, is it able to predict, as I say, that it has learned. If it's not able, then you go back and fine-tune your parameters, or go back and select a new model. If you are happy with the output, now you have a model that now you can use for other related problems using more or less the same data. So if you have new data, you can just feed into the model knows what to do from there. Going straight to the same thing, just emphasizing this point. The first phase is that you're gonna have to do the learning, you are training the model. So learning, you have to clean your data. Normalization, talking about scaling of your data, ensure that you have the same units if you're using different units for a particular feature. Dimension reduction, image processing, depending on what you are dealing with. And then you have three parts of learning. You have supervised, unsupervised, and reinforcement. And we'll look into that in the next few slides. And then once you train the model, you will then, as I spoke earlier, around the issue of accuracy. Now this is error analysis. You're now going to have to look at the model. Is it able to predict generally, or it is predicting specifically? That means if I put new data, it's not going to be able to predict. That means it's predicting specifically. That means it's overfitting. So you want your model to be general, so that any new data can learn from it and be able to predict. We'll deal with overfitting and underfitting in the next webinars. But for now, just know that we don't want specific prediction, like 100% accuracy. We don't want that. We want an acceptable level of accuracy, depending on the problem at hand. Then once you have that model that has been tested and it's been found to be good in a sense that it's able to predict accurately, you take the model, you feed it with new data, and then it runs through the prediction process. From there, then it will give you the predicted result. And again, the predicted result can also be tested in terms of using error analysis, in terms of looking at the accuracy levels of that predicted output. So as I said in the previous slide, machine learning has three learnings. We have supervised, unsupervised, and reinforcement. So under supervised, we have various also algorithms, regression, decision trees, random forests, and then for classification problems, you have your KNNs, you have your other trees, naive Bayes, your support vector machine algorithms. But I'm not going to deal with this for now. This will be done later. Just for now, just to know that there is this kind of categories. And then for unsupervised learning, you have clustering, association analysis, and then you have reinforcement. What is key that one must take away from this slide is the data type. The data is either continuous or categorical. If the data is continuous, it describes information that can take virtually any value. That means you're looking at numbers and simplicity. If you say you're working with numbers, that is continuous data. So you can see which algorithms work with continuous data. You have regression, decision trees, random forest. Then under unsupervised learning, you have your PCA, your K-means. Then if you are dealing with categorical data, This is data that is sorted into predetermined or predefined categories. It does not involve any numerical values or measurements. So it's like categorical data can be like male or female, white or black, truck or car. Those are categorical data. So once you know the data that you have, it then becomes easy to select the appropriate algorithm that can be used for your model. So let's look at the first subset of machine learning, which is supervised learning. So here, what we learn from supervised learning is that the algorithms learn from the labeled data. That means the data that you bring in must have labels of features. And then that is assists to classify the data and also predict the outcomes. So in this case, we have an example. Let's look at group one. Group one, we have those pictures. Just focus on the colors. The pictures are gray in color. So the model will learn that, okay, these pictures, these are looking at classification problem. These pictures, they're like this. This means they're gray. So if I take a gray color, these I can group together. It learns that. And then now I feed it new data. This is step 2. When I feed new data, now I feed this. In this case, I have orange color. It should be able again to learn, because I've trained the model to learn and issue a grouping of the grayish color and also the grouping of the orange-like colors. That's how then the output will look like. If it does that, that means it's a good model. If then it will probably in group 1 have an orange block there, that means it's a bad model. That means we have to retune. We'll go back to fine-tuning the model. That is looking at the weights or parameters that we have chosen for the model, or probably even our data set is not adequate. Maybe we have limited data, and that means we need to add data. Looking at unsupervised learning is it uses the machine's algorithm to analyze and cluster unlabeled data set. That means we don't tell it this is the input, this is the output. We just give it data and say solve the problem. So it's normally used for pattern recognition and also grouping. So in this case, you can see in step number 1, we have gray and orange blocks, and then these are uncategorized, and then we put it through the model, and then the model will then learn those patterns. And then step 2, after learning, it will then separate them into 2 groupings. Similar group 1, similar group 2. Orange is on one side, and then also in group 1, we have only the gray scale. So if, for instance, in group 2, you had a gray scale, that means the model is not good enough. Therefore, it means you have to fine-tune the weight or the parameters until it works best. So where one can use, as an example, unsupervised learning, let's look at clustering. We are looking at, are there any patterns in the geological data to indicate certain mining sites will yield higher or greater than the others? So by feeding it different grade distributions of the ore body, continuously feeding it those images or those patterns, you can actually learn and tell it, no, this block will have high grade, this block will have low grade. So you can get your grade distribution just by using previously known information or historical data. Another part is detecting anomaly in your system. For instance, you can check if there's any hacker that is intruding in your control room network, for instance. How do you do that? You feed it the different actions that are taking place in your network. So that is your digital signature. Then you can be able to pick up that. It should then, something has come, it will pick up that, no, there's an anomaly. Then you can easily be able to track and check why there is an anomaly. Is the system failing or there's a hacker, something of that nature. So these are just broad examples. The last point is the reinforcement learning. Is about taking suitable actions to maximize reward in a specific situation. So it works on, if you fail, you get penalized. If you pass, then you get rewarded. So what we have here, maybe I just explain this a bit. Reinforced learning uses agents which interact with the environment. And as in the environment, they will perform certain actions, then they'll be getting feedback. As I said, if the action is correct, it's get a reward. If the action is incorrect, it will be penalized. They need to know and remember that penalty. Then the agent learns by trial and error, adjusting its behavior to achieve the optimal outcome. So in this case, we have an apple as an input. You give the model an apple, and then it responds and says it's a mango. We give it feedback and say, no, it's wrong, it's not a mango. Then we penalize it for that. Then it will go back and learn again. So it will take that to receive the feedback and say, okay, noted, I get the feedback. And then it goes and learn again. After learning, it will come and say, look, it's an apple. Then you say, yes, it's correct. Then the model, then that means the model is working accordingly. That means the level of accuracy is high. Then you can be able to use. So it normally works best with images as well. So this is just looking at in a nutshell, looking at machine learning, looking at supervised learning, unsupervised learning, and also reinforcement learning, which are all subsets of artificial intelligence. Now, there are pros and cons, of course, for machine learning. So looking at the advantages, it is easy to identify trends and patterns from your output, and it requires no human interventions. Once, of course, you have developed the model, in terms of solving the problem, it works independently. And then it gives you continuous improvement. As we feed it new data, it gets that data and it learns from it as well. So it's continuously learning. And that means your predictions as well will also be will have an improvement. And then, of course, it can be applied in different areas. As we have mentioned, all sorting can be used, machine tracking can be used, predictive maintenance, even in our plants can be used. So there's a variety of areas where along our mine value chain where we can be able to use machine learning solutions. It is, of course, susceptible to high errors. This is solely based on the data. If your data is not good enough, of course, what is going to output is going to be poor output. Then in terms of the data acquisition as well, it's getting data for our operations can be pricey or costly. In terms of if you don't have sensor base, you have to collect data manually. That might now consume more time and also a high cost. To process this model, looking at our data that we have in the mining space, requires high performance computers. That means now that it increases the cost of resources required, and some data may need to be stored in the cloud, for instance. That means, again, that increases your cost in terms of resources required for you to be able to apply machine learning. The interpretation of result also requires someone who's skilled to understand the problem at hand. So that means you still need someone who will be able to interpret the output and be able to identify anomalies in the output. So that, in a nutshell, are the pros and cons of machine learning. However, what we can pick up here is that we have to, as the mining industry, we have to move towards digital transformation and ensure that we apply these artificial intelligence models where appropriate, of course, in order to improve our efficiency and our business as a whole. Okay, thank you very much for that question. So, look, the challenges will stem from the value chain of implementing AI. So one will start from the infrastructure side. Your mine, your operation need to have the infrastructure in place, be it in your network side or even just the hardware side. So that means we have to work with the IT departments or in personnel to determine your readiness in terms of infrastructure first. And then the other part is, where do we store our data? Noting that there is a necessity to protect the data of the company. Do we store it in the cloud? Do we store it in our own personal servers on site? If you do it on site, probably the risk of hacking is less. But if you do it on the cloud, that means you have to now invest in cybersecurity. And then, do you have the data? That's a critical thing. What type of data do you have? Is the data adequate in terms of amount and structure for it to be used in these models? So those are the major things. And also, there are hardware that one can buy and apply in the operation. Can I put or attach a value amount, be it in cost savings, be it in profits, or be it in efficiency, on that particular hardware, on that particular technology? Can I actually be able to say this technology has assisted in this manner? Be it as, if you're looking at health and safety related technologies like your wearables, can you be able to say, now if as employees are wearing those wearables, I'm able to monitor their well-being in terms of health? Can you put a tangible value on that particular product? So it starts from infrastructure. In a nutshell, it's infrastructure, is the data availability, and then also is the end goal. Are you realizing that we have set out as an objective when applying that particular technology? No, thank you very much. Yeah, so it can be used. I mean, if I use drones as an example here, you're now easily able to fly your drones over your tailings dam, your dump site, and get good images there, which you can later analyze to determine the stability of your tailings dam and your dump site, or even your stockpiles as well. So you can use it like that. And also, as we spoke earlier about the opportunity that comes from machine learning when looking at exploration. Before, in the traditional way, you will suspect that the farm has some area of interest. Then you pull in your drill rigs and you start drilling holes. Now, using the AI in exploration, now you can fly drones, get images there, and then you can do a spectrum analysis. Then from there, before you can even drill the first hole, of course to be compliant with the law, we already know that there is something here or not before we start drilling. Then you look at the potential, and then you can easily identify even specific areas where you should concentrate your drilling, not drilling throughout the farm blindly. Thank you.